Greetings. My name is Mike Levis, and I'm an instructor with the Mountain Hood Ski Patrol Avalanche Program. The topic of this presentation is basic avalanche rescue equipment. In the following, we will present an overview of basic rescue equipment and a brief introduction on how to use this equipment. You'll get much hands-on experience with this equipment and a chance to polish your skills during the field sessions. Rescue equipment has progressed tremendously over the last 10 years. Beacons have more functions that, if used properly, should result in locating victims more quickly. AVI airbags have reduced the depth of burials and saved lives. However, as you learned in human factors, as equipment improves to reduce risk, people tend to develop a false sense of security, actually taking greater risks. Taking greater risks offsets any benefits you may get from equipment improvements. The basic rescue equipment that should be carried by each member of your party are beacon, probe, and shovel. Full stop. No one should leave the parking lot without these. In addition, there should be at least 2 first aid groups in your kit. Why 2? Well, what if first aid kit on one person is on the victim who gets buried? Then you need to have a second first aid kit in order to deal with the victims. In what follows, we'll go through each of these in more detail. We'll also touch briefly on the Avalon and Avalanche airbags. Let's start our review of AVI rescue equipment with an overview of beacons. All modern beacons have 3 antennas for improved signal detection. All beacons are standardized to operate at 457 kilohertz, which ensures that beacons from one manufacturer can detect signals from another manufacturer. The most common mistake people make with beacons is not understanding how to use their beacon. Whatever beacon you use, you need to make sure you understand the basic features of that beacon and how to use them. Some of the critical functions include range. How wide a search path can you implement? Multiple burial functions. How do you flag a victim once found so you can move on to other victims without interference? Display. Is it in feet or meters? Can you see it in all light levels? Battery life. How can you tell how much battery capacity remains? What are the specified useful hours in both transmit and receive mode? Coarse and fine search. How does your beacon indicate these phases? Make sure you understand how your beacon functions and practice with it regularly. Now at the bottom of the slide, you'll see a URL, www.beaconreviews.com. If you really want to geek out on beacons or want to do some research in any particular model of beacon, that really is the go-to place, www.beaconreviews.com. So let's review the phases of a beacon search. There are 3 phases: signal search, coarse search, and fine or pinpoint search. Phase 1 is the signal search. During this phase, you're going to try and detect a signal from a buried victim. Start at the last seen point and descend downhill in a strip 40 meters wide. Move fast. Remember, speed is of the essence. The next phase is the coarse search. It starts with when you detect a signal. When you detect a signal, let others know. From this point, follow the arrows or LEDs on the display. The final phase starts at 3 meters from the victim. During this phase, you should be low to the surface and following the numbers on the screen. You're looking for a minimum. When you reach a minimum, you're going to mark a pinpoint probe box for probing. More on this to come. And as you can see in this slide, our goal here is from the time we start the search until we have finished our pinpoint probe box to be 3 minutes or less. You can also see on this slide that when you start on the signal search at the top, whether you do a serpentine pattern or go in lanes down the slide path, which we'll talk about here in a second, it's really a function of how wide the slide path is, how many searchers you have to work with, and the range of your beacons. The signal search can be implemented in several ways depending on the number of searchers, the range of the beacons, and the width of the slide area to be searched. The preferred technique with multiple searchers is shown on the left. Each searcher is assigned a lane and progresses rapidly down his or her assigned lane until one of the rescuers detects a signal. For a single searcher, a serpentine path down the slide path is the most efficient search technique. It's important that the alternating legs in the serpentine be close enough so that there are no uncovered areas in the search. If the legs of the serpentine are too far apart, there'll be dead zones in between each leg that are uncovered. So you can see in this case, the legs are 30 meters apart. So if you had a beacon with a 40-meter range, you would have basically a 10-meter overlap between legs, and you'd be making sure that there'd be no uncovered area. So as you're on one leg, for example, you have a 40-meter range. Your beacon is searching basically 20 meters on each side of that leg. Once the signal is detected, the course search starts. When thinking about the course search, it's important to have an idea of how the beacon works. The victim's beacon radiates a three-dimensional pattern that is detected by the three antennas in the rescuer's beacon, as shown in the figure. The rescuer's beacon follows the flux pattern towards the victim. The signal is strongest when the rescuer's beacon is parallel to the flux lines. Several points to note. Because the rescuer's beacon follows the flux line, the rescuer will follow a circular pattern to the victim, not necessarily a direct straight line. Note that the newest beacons use software to calculate a straight line path to the victim. So depending on your beacon, you may follow a circular path or a straight line. So you really got to know your beacon. As you can see from the figure, there are two paths to the victim. Depending on which direction you're heading, if the numbers on your beacon start getting larger, try turning 180 degrees and see if the numbers start dropping. Note the sample rate on your beacon limits the rate at which your beacon can update the distance reading. Most beacons update at a rate between 0.7 and 1.3 seconds. If the readings are jumping erratically, slow down slightly. You're probably outrunning your beacon. Note the beacon is telling you the distance to the victim's beacon, including the distance down below the surface. This means that if you lay your beacon on the snow directly above a victim, the reading will not be 0, but will be, for example, 1 meter in the case of a 1 meter burial depth. This will be important to keep in mind when we do the next step, the find search. The course search continues until you are 3 meters from the victim, at which time you begin the find search. Once the rescuer's beacon indicates 3 meters, the rescuer starts the find search. At this point, the rescuer should have the beacon as close to the surface of the snow as possible. Our goal during the find search is to define a small box on the surface of the snow that will be our starting point for probing. Let's look at how this works using the diagram on the slide. The rescuer is on his knees on the snow, and the beacon is reading 2 meters. So you can see we're starting at the left-hand side of the illustration there where it says start. Depth the beacon is reading 2 meters. The rescuer slowly moves the beacon to the right, looking for a minimum reading. In this case, the reading is 1.4 meters. The rescuer marks the minimum, then continues sliding the beacon to the right until the signal starts to increase, in this case to 1.6 meters. The rescuer marks this point as the rightmost boundary. The rescuer goes back to the minimum, 1.4, and slides the beacon upwards in the image, again looking for the signal to increase. When the signal increases, the rescuer marks the top boundary. So it goes from 1.4 to 1.5, 1.6, oh, it's starting to increase, so mark the top boundary. You could have marked it at 1.5 just as easily. The rescuer now slides the beacon down, again looking for numbers to begin increasing. In this case, the numbers drop below the minimum 1.4 and a new minimum of 0. is discovered. So it goes 1.4, 1.2, 1.0, 0.8, okay, and then it starts to go up again, 1.0, so 0.8 is the minimum. The rescuer repeats this process around the new minimum, defining a new box. In this case, when the rescuer slides the beacon to the right, yet another new minimum is encountered, and the process repeats until we've identified a box around the true minimum. So he slides to the right, goes 0.8, 0.6, 0.5, oh, 0.6, so it looks like 0.5 is the minimum, so you mark that. Slide to the right, oh, 0.6, mark that. Slide up, oh, 0.6, mark that. Slide down, 0.6, so in each direction it's going up, so 0.5 is your true minimum, and you've defined the box around it with the next level increment up at 0.6. Some points to note in the find search. It's important to get as close to the surface as possible. It's important that the orientation of the beacon remain fixed. Rotating the beacon or raising and lowering the beacon will affect the reading and the accuracy of the find search. One issue to keep in mind while conducting a beacon search is interference from the devices such as cell phones, GPS devices, and the like. This graph shows the results of research conducted by John Barkhausen in 2012 on the magnitude of interference as a function of distance. As you can see, the interference can be significant for devices that are in close proximity, 20 centimeters or less. The latest generations of beacon has more ability to reject these interfering signals, but it's still a good practice to keep other devices well apart from your beacon. This is particularly important during a search. Put all your other devices in your pack and make sure they're turned off. Let's shift gears now and talk about probing. This slide gives some general guidelines and considerations for probing. You'll get a lot of probing practice during our field sessions. Probably the most important point is to use a methodical, consistent pattern. Haphazard, disorganized probing almost ensures you're going to miss the victim and waste precious time. Be disciplined and use the technique we're going to discuss. You're going to probe to feel. You're not trying to impale or perforate the body. A body has a spongy feel and has some give to it. Once you have a strike, it's critically important to leave the probe in place. Let me repeat that. Once you have a strike, it's critically important to leave the probe in place. There are three main types of probes you'll see. The kind we're going to use, that you use almost exclusively, are collapsible segmented poles. They come in lengths from 240 to 330 centimeters and are typically made of aluminum or carbon fiber. They'll have markings etched or painted along the length of the probe to measure depth. Critical with segmented probes is the deployment and locking mechanism. You should be able to deploy the probe in literally a second or two, and it should stay locked when deployed. There are ski poles available that can double as a probe. They generally are shorter in length and not as useful as a probe to rescue buried victims. Organized rescue teams may use one-piece probes made of steel conduit. These are fairly awkward to carry, but have the advantage of being cheap. So let's discuss the correct technique for probing. Again, you get a lot of practice of this during the coming field sessions. Start probing at the minimum point you isolated in the Find Search box. The probe should be oriented perpendicular to the surface. If you do not get a strike at the minimum, move the probe 10 inches out and probe in a circular pattern around the minimum point. If you do not have a strike after completing a full circle, move an additional 10 inches out and repeat. If you do not have a strike after completing 3 concentric circles, you need to recheck your beacon readings. Some things to note. If there are buried ice layers, you may need to apply some force to break through the buried ice layer. Your beacon will give you a reading indicating the depth of the buried victim. You can correlate this to the depth marked on the side of your probe. They should be consistent. The orientation of the victim in the snow can impact the likelihood of getting a probe strike. The most difficult situation is a victim that is oriented vertically, i.e. standing. This gives a very small target to hit. Precision in marking the minimum and the thoroughness in probing is critical for success in this situation. There are many styles of shovels on the market. Some have blades that can be oriented like a hoe, some have ice saws in the handle, some have collapsible handles. The only real absolute is that it must be metal. Plastic shovels will break and are not acceptable for avalanche rescue situations. Shovels with a collapsible handle can pack into a smaller size and are easier to transport in your pack. Pick one with a blade that matches your size and strength. Shoveling is the most time-consuming aspect of any rescue, so we want to be smart about how we shovel. We want to start downhill from the victim about 1.5 times the burial depth and dig horizontally until we think the victim is. So if we've left our probe in like we should have, we have a reference point to aim for. We only want to handle the snow once, so snow should be shoveled downhill all the way, out of the way. If we have multiple shovelers, we want to be oriented in a V pattern as seen on in the graphic on the left-hand side of this slide. The lead shoveler moves the snow back, and those behind him move the snow downhill and create a platform. Shovelers should rotate every couple of minutes. Note, we try and avoid standing on the victim and digging straight downward, as shown in the image on the right. Why do you think this is the case? Think about it, and we'll talk about it in class. So let's talk briefly about the avalon. In order to understand how the avalon works, you need to understand what's happening with the buried victim. As the slide settles, the victim's breath condenses around his mouth and forms an ice mask. The ice mask is impervious to air, and the result is the victim suffocates. The avalon has a mouthpiece that connects to a hose that goes around to the back of the victim. When the victim breathes, air comes from the back. When the victim exhales, air is shunted away from the victim's face, preventing the formation of an ice shield. This extends the time available to find and rescue the victim. The challenge with the avalon is to make sure the mouthpiece is not ripped out of your mouth when you're tumbled in an avalanche. An airbag is the most recent advancement in personal safety equipment. Airbags come as part of a backpack and have a mechanism that deploys and fills the airbag when triggered. Airbags are intended to increase your size, enhance buoyancy, and keep you near the surface as you're caught in an avalanche. As the image on the top left here shows, the airbag inflates, the victim in this case becomes more buoyant and is forced towards the surface. Note, airbags are additional safety equipment and do not replace a beacon. So airbags do make a difference. This slide shows data on burial depth with and without an airbag. So the graphic on the left is with an airbag and the graphic on the right is without an airbag. And you can see the difference in burial depths. You can see that with the airbag, the burial depth tends to be very shallow. In most cases, it'll be only a partial burial. As you can see, burials when wearing airbag are much shallower. This means that the victim can be found and extracted in a much shorter time and have a much higher likelihood of survival. The downside of the airbags is that they're expensive, $800 to $1,500. So that brings us to the end of our module on rescue equipment. For pre-work, please watch the following videos demonstrating many of the techniques we have discussed. Again, you will get a chance to practice all of this during our field session. Thanks again for your time.